Hi everyone, so today we're taking notes on 3.3 in calculus, and it's about the derivatives of the trig functions. So before I start examples, I have to tell you the 6 trig derivatives, and honestly if I were you I would make flashcards, 6 of them, so you can memorize these. So number 1, the derivative of the sine function is cosine x. 2, the derivative of cosine is negative sine x. Remember, d over dx means the derivative of. The derivative of tangent x is equal to secant squared x. That's not x squared, it is secant x quantity squared. It's the function squared, not the argument squared. 4, the derivative of cosecant, which is the derivative of sine, is negative cosecant x times cotangent x. Okay, that's the derivative. 5, the derivative of secant x, which is the reciprocal of cosine, is equal to secant x times tangent x. And the last one, the derivative of cotangent x is negative cosecant squared x. I've noticed a good way of kind of memorizing these, or starting to memorize them, is any function that starts with a cosine, cosecant, cotangent, those 3 that start with a co, their derivative is negative. And if you don't have a co, like sine, tangent, and secant, their derivative is positive. So that's a good way of kind of starting to memorize these. All right, so examples. First of all, let's start with the easiest one. If y is, so we're going to differentiate all of them. That means we're going to find the derivative. So whatever I write, we're going to differentiate. So if y equals 5 sine x, what do you do with the 5 multiplier in front? Well, if the multiplier is a constant, it goes with you. So the derivative of sine is cosine, so the derivative of 5 sine x is 5 cosine x. Done. Okay? If you can't remember, if you are wondering why, I'm going to only demonstrate it once here. You can treat 5 sine x as a product. And if you apply the product rule, look, the product rule says, if this is f and this is g, the product rule says f prime, what's the derivative of a constant? 0, times g, plus it says g prime, what's the derivative of sine? It's cosine, times f. So f prime g plus g prime f. And if you look, 0 times sine is 0, plus 5 times cosine is 5 cosine, 0 plus anything is itself. So there it is. I really would not want you to do the product rule, okay, because it takes longer. But anytime you have a function, any function, and you're finding its derivative, but it's got a constant in front of it, you may transfer the constant to the derivative in front of it, okay? Number 2. So, like if I had y equals negative 8 cosine x, and I ask you for y prime, first of all, negative 8 as a constant, so you're going to transfer it to the derivative. What's the derivative of cosine? It is negative sine. So the answer to this problem would be positive 8 sine x. Okay, moving on. I have several examples here. Let's see. What if I have, oh, I know. Y equals e to the x sine x. So first of all, you have to realize you've got a product on your hands, so you're going to have to use the product rule. So remember the product rule, f prime g plus g prime f. This is f, this is g. So the derivative of our function would be, okay, so f prime, the derivative of e to the x is e to the x, times g as is, sine x, plus g prime, the derivative of sine x, you're going to memorize, is cosine x, times f, which is e to the x. And so, you know, this is, I encourage you to factor your final answer if it's within reason, if it's easy to factor. And this one is. So I would factor out an e to the x, parentheses sine x, plus cosine x. Done. Let's do another one. What if I have f of x is equal to sine x cosine x? Again, you have to recognize that this is a product. So using the product rule, which says f prime g plus g prime f, now I have f here, so let's not confuse. Product rule says derivative of first, so the derivative of sine is cosine, times second, so cosine again, plus the product rule says the derivative of the second, so the derivative of cosine is negative sine x, times the first function. And so you get cosine squared x minus sine squared x. And I do believe you can either leave it this way, or if it were a problem where we have to set this equal to 0, like if the problem said find where you have a horizontal tangent, you know, you would set this, the derivative equal to 0, you'd have to factor. You would realize this is the difference of two squares. You would factor like that, okay? So maybe you would have cosine plus sine times cosine minus sine, or you'd realize, oh, this is the double angle formula for cosine. So cosine 2x, either one, okay? All right, let me do another example. Number 5, example 5. So we're still differentiating, same directions. Find the derivative, which means differentiate. All right, cosine theta over 1 minus sine theta. Oops, I forgot f of theta. F of theta equals. Okay, so we have to realize that if we're finding the derivative of f of theta, you know, we have a quotient. And the quotient rule, let me write it here as a reminder, is f prime g minus g prime f over g squared. You know, maybe I'll use a different letter here, like an h. Sorry, now I'm just being messy. So h of theta equals, so over here, h, just so we don't get our f and g's confused with this f that I had. So f is the top, g is the bottom. All right, so if we follow the quotient rule, we have the derivative of the top, which if you look at your notes, the derivative of cosine is negative sine, times g, which is literally the bottom as is, minus, it says, g prime. So now we have to do the derivative of this. What's the derivative of 1 minus sine theta? The derivative of 1 is 0, minus, not theta, 0. The derivative of sine is cosine theta. And then the quotient rule says times f. So just times f. F is the top, cosine, all over g squared, which is 1 minus sine theta, quantity squared. We don't ever have to FOIL out the bottom. And so if we clean this up a little bit, I'm going to distribute. I've got negative sine x. I am switching between x and theta. That is not good. Sorry, this turned out to be a very messy problem. Negative sine theta plus sine squared theta, I'm distributing. I'm going to distribute this way. So I'll have, this is 0, so it really doesn't count. I've got negative cosine theta times cosine theta, and then also another negative. So it'll turn to plus cosine squared theta all over 1 minus sine theta quantity squared. And we just leave it. I don't have any like terms here. You can't factor this, so you leave it. Let's do another one. Hopefully I won't make so many ugly mistakes. What if h of t equals t squared cosecant t? Again, you have a product, t squared times cosecant t. So the product rule says f prime g plus g prime f, okay? That's the product rule here. This was the quotient rule. All right, so let's start. If this is f and this is g, so the derivative would be, okay, f prime, the derivative of t squared is 2t times g, just the way it is, plus it says g prime, what's the derivative of cosecant t? If you look at your notes, the derivative of cosecant t is negative cosecant t cotangent t times f, which is t squared t. Ugh, my x's and my t's. So I'm going to write this out. I think it's factorable, so I'm going to factor it if I can. There's a t and a cosecant I can take out. So I'll go t cosecant t parentheses, leaving me with just 2 minus, I factored out a cosecant, I factored out a t, so there's still a t here, cotangent t. Maybe t was not the best variable to use with cotangent. Okay, but there it is, it's done. Number 7. Oh, this is a different one. Prove one of the derivatives. Prove that the cosecant x derivative is what we wrote down. Cosecant x, cotangent x. So this is at the top of your notes. We wrote that down right here. Okay. It's derivative number 4 under the trig derivatives. So it says prove it. Okay, well if I have to memorize that the derivative of cosecant x is equal to this thingy, I have to somehow get here, okay? So I have to think outside the box. How else could I write cosecant x? Well, I know that the derivative of cosecant x itself is the reciprocal of sine. So I can totally write that as its reciprocal equivalent. Cosecant x is equal to 1 over sine x. They are reciprocal functions. Just like sine x is equal to 1 over cosecant x, well, cosecant x is equal to 1 over sine x. They are reciprocal functions. So we realize we have a quotient rule on our hands now. Okay, right here, something over something. Quotient rule says, so if this is f and this is g, quotient rule says f prime g minus g prime f over g squared. I'm going to go through that process. Here I go. So the derivative of f, the derivative of 1, which is a constant, is 0, times g, so sine x, minus g prime. What's the derivative of sine x? It is just cosine x, times f, that's just 1, over g squared, sine x quantity squared. Okay, if you look, 0 times anything is 0, so minus cosine x is what I have so far, over sine x quantity squared is actually sine x times sine x. And if you group some stuff together, what is cosine x over sine x? Is it not cotangent to x? That's the definition of cotangent. So you will get negative, that's cotangent x, and then I've got times 1 over sine x. Well, what's 1 over sine x? Look, it's cosecant x. So it has been proven. QED. What does QED mean? QED means quod erat demonstratum. It is a Latin phrase that means it has been demonstrated. So at the end of proofs, mathematicians put QED. All right, I've got just a few more. Let's see. Number 8. Oh, I know. Find the tangent line, or the equation of the tangent line at 0, 1. If the function we're talking about is e to the x cosine x. Okay, So there's the point we're going to use. Everyone knows at this point in time, in order to get the equation of a line, you need a point, so check, and you need a slope. Slope means find the derivative. Okay, here we go. We have a product on our hand, so we're going to do the product rule, which says derivative of first, the derivative of e to the x is itself, times second function, plus derivative of second function, so negative sine x, times first function. All right, so if this is my derivative, honestly, I don't even want to bother factoring because I'm looking for a slope. Okay, I'm looking for a slope, which at 0. So all I want is f prime of 0, so I just want to plug in a 0. Factoring is just going to be a waste of time. So e to the 0 times cosine 0 minus sine 0 times e to the 0. Well, anything to the 0 power is 1. Cosine of 0 is 1. Sine of 0 is 0. E to the 0 is 1. All this boils down to 1. You guys, this was the m in our y equals mx plus b. So I've got a point. I've got a slope. I'm going to use the point slope form, m x minus 0. And so in slope-intercept form, if I move the negative 1 to the right, I'll have y equals x plus 1. This is my tangent line. All right, I'm going to do, I think, one more. Sorry. So for what? No, this is, sorry, change my mind. Hold on. That's not the one. I'm going to finish the notes here with one thing I have to tell you. So you have to memorize, and I will prove these to you in chapter 4, 2 limits, which are a part of the trig derivatives section. Okay, here's one limit, but they will be proven to you in chapter 4. The limit, which one do I want to do first here? The limit as x approaches 0 of sine cx over cx. C equals constant, like 3 or 5. So if this said sine 5x over 5x or sine 8x over 8x, this limit is equal to 1. And so is its reciprocal. Limit as x approaches 0 of cx over sine cx is equal to 1. So if I say, you know, what's the limit as x approaches 0 of 7x over sine 7x? The answer is 1. Okay, you just give me the answer. There's another one you have to memorize. So you have to memorize number 1, and this was example 1. So memorize. Here's another one. Limit as x approaches 0 of cosine x minus 1 over x. That's equal to 0. But this is the one we're going to use most often. Okay, this one. So I want to do an example. And that example is this. Find the limit as, let's see what I want to do, x approaches 0 of sine 5x over sine 2x. Okay, you know, I'll tell you, people oftentimes want to cross out sine or you reduce. You cannot do that here. This is not multiplication. It's not sine times 5x. It's not sine times 2x. This cannot be reduced. So what we're going to do is we're going to try to force it to look like this. The problem is, if this said sine 5x over 5x, we would be golden. Okay, I would say the answer is 1, but the problem is it doesn't say that on the bottom. Or if it said 2x over sine 2x, then it would look like this and I'd say the answer is 1. So what I'm going to do is I'm going to force it to look like that. I'm going to manipulate the fraction. So first of all, I'm going to split the fraction into this. Okay, because you can. This is a property of multiplication. You can totally do that. The next step is going to be, watch this. I'm going to strategically take these two fractions. I'm going to very strategically multiply the top and the bottom by a version of 1. You can multiply a fraction by 1 anytime you want. It won't change it, as long as whatever you multiply by actually equals 1. But the 1 I'm talking about is this, 5x over 5x. 5x over 5x is 1, right? In fact, I'm also going to multiply it by another 1, because it doesn't change anything when I multiply by 1, and that is 2x over 2x. And then I'm going to rearrange the multiplication the way I want to rearrange it. So I'll have limit as x approaches 0. I'm going to write this one over this one, so sine 5x over 5x times this one over this one, so, or sorry, this one over this one, 2x over sine 2x, times whatever I have left over. You know, the 1 over 1 I don't have to write, but I do have 5x over 2x, which, by the way, reduces 5x over 2x is just cross out the x's, is 5 over 2. You guys, the property of limits says if you have a limit of something times something, you can split it into 3 limits. Limit of this times limit of this times limit of this, which means you can evaluate them separately and answer the question. This first limit looks like that, so the answer is 1. Times this second one looks like this limit, so the answer is 1. And then the limit of a constant is a constant. The answer to our problem is 5 over 2. And I'm planning on doing more with this in class. I think that's all, folks. And I shall see you in class to talk more about this. These were the trig derivatives. Please make 6 flashcards, maybe 8, with these two on there. And that's it, the end. Thank you. Bye.